Hello to everyone and welcome on the YouTube channel School for All. If you are discovering this channel through this video, I'm called Polar Eve, a computer science and ICT teacher. So on this channel, you are going to find videos concerning all your different practical sessions, whether you are doing ICT or computer science. So videos on programming, database, Microsoft Excel, and so on are available on the YouTube channel. So the first thing is make sure you have subscribed to the YouTube channel, and each time you are done with a video, like the video and leave a comment. So thank you. Let us start the video. So today we are going to answer the programming part of June 2025. Computer Science Advanced level. So I'm going to show you exactly how you are supposed to think when you answer such question, and from there you'll be seeing that everything is very easy. If you have any problem, drop a comment and I will reply to you. So before you watch this video, I invite you to do two things. The first is like the video. If you are not yet subscribed to the YouTube channel, make sure you subscribe to the YouTube channel. It's very important for us. Now, you don't have time to watch the full video because the aim of watching this video is I'm explaining everything in detail, how you're supposed to reason and so on and so forth, how to answer past questions. Because as I'm always telling my students, all your different type of question, there is a technique in fact to go through the question. By the time you don't know that technique, in fact, it becomes very difficult for you. So that's the aim of my videos. Good. So now there's one document here, Advanced Level Computer Science Paper 3. So this is the solution of that paper 3. I did it in form of PDF. You see, good. So if you don't have time to watch the full video, this is the PDF document here. You can just go through the PDF document and you do the practical. It's very interesting. Very interesting. Good. But I will be doing all this in the video, good, because in the video I'm explaining, even though in the document I'm also explaining, like here paper 3, question 3, you see I'm explaining before writing the code and so on and so forth. So question 4, explaining before writing the code. Document is very interesting. So where to find this document? This document is available on the platform School for All. Good. If you have any problem to access this document, just leave a comment. I will send the document to you. Now, so we are going to start without wasting time. So this is the question here. Now, section B, programming development. So we read the question together and we start. Using your preferred programming language, C or Pascal, that in advanced level work with C programming language. Good. So generally we are not working with Pascal. Good. So ignore this part. And integrated program development environment. So the IDE is simply representing the software that you'll be using to write your program. And the IDE that we are going to use here is Dev C++. If you don't have the software, just drop a comment. Let me send you the link to download the software. Now, IDE, okay. Carry out the following programming tasks. Note that comments with questions start from a double slash to the end of the line, or are between slash star and star slash. Good. So yeah, they're just helping you. They're just telling you that anything starting with this double slash represent a comment, or any text in between this slash star is a comment. Now this is where the question starts. Game of life, task description. Now I plead you people, programming is not difficult, and generally what happens with programming, you have the pseudocode, so you just translate this into a C program. And the best thing is that you don't even need to understand all this pseudocode. No, the only thing that's very important for you is to know how to translate from pseudocode to C programming. It's all. You don't need to understand everything. No, you don't have that time, in fact, in the exam. At least there are certain functions that you need to understand the logic and so on and so forth, but not in detail because you don't have time. But what is important for you is to understand the program description, is to understand the equation, is to understand your task. Because if you don't understand the task, it's finished for you. All these functions you'll be translating without knowing what you're translating. Good. So the idea, I repeat myself, is understand the program description. Understand what they're asking you to do. By the time you're understanding this, everything becomes very easy. Like when you be translating the pseudocode in fact is like answering the question that you need, in fact, from the program description. Like imagine that your program description is saying that at a certain point we are doing calculation of two number and we have our result. Now, and there's a pseudocode that calculates the sum of two numbers. Good, and display the result. So you are seeing that at the end what happened here, you know the aim of the pseudocode. You know that, okay, if I translate this pseudocode, I'm supposed to give two number and he's supposed to give me the result. So this is what happened. So you are seeing that you don't even need to understand the pseudocode in detail, how he's doing that and the rest. No, you just make sure you translate it very well. And for you to translate it very well, you need to have some knowledge in C programming language. Exactly. So you must master C programming syntax. Because if you don't know C programming language, how are you going to translate? It's not possible. Like, how are you going to, let us say you don't know, you have never manipulated arrays. So how are you going to translate array from pseudocode to programming? You see where the problem come in. Good. But by the time you have all this knowledge, in fact, everything becomes very easy. The only thing you need now is the technique, and this is exactly what you'll be learning through this tutorial. So watch this video till the end, and I'm sure you will learn something. So at the end of the video, don't forget to drop a comment for me to know your impression. Now, so we're going to start game of life task description. They say Conway's game of life, or just life. So either we call the game Conway game of life, or you just call it life. It's a cellular automaton which evolves life and death cells within a grid or board. Good. Like here, if you look under here, you realize that this is a grid here. Good. And they say that this grid here contains life and death cells. So 1 is life and 0 is dead cell. Now, the question you ask yourself is, how do I know that 1 means life cell, 0 means dead cell? So the next advice I want to give you people is that when you have a question, make sure you read all the question from start to end for the first time. Now you come back again and you read the question for the second time. So if I know that 1 is life, 0 is dead, it's simply because I read the question all. So I'm just reading it back, in fact, for you people in the video. So, and it's exactly the same behavior you're supposed to have in the exam, because some students are very funny. You start a question, you just read one part of the question, and for you are seeing that, man, it's difficult, I'm blocked, whereas you never go through all the questions. So take note of that. Okay, so I'm just reading very fast. So Conway's game of life, or just life, is a cellular automaton which evolves life and death cells within a grid or a board. So this is here represented as a two-dimensional array. So this is a two-dimensional array here. So you are seeing that in this here you are manipulating a two-dimensional array. So you see that if you don't know how to manipulate two-dimensional array, this is where your problem starts. That is why knowing all the different concepts is very important. And on my YouTube channel, I have multiple videos, in fact, under programming language. I have so many videos concerning programming language in all the different aspects. Good. If you have a particular problem, watch them. Now, full stop, continuation. Grid cells are either alive or dead and evolve in successive generation as determined by their neighbors. Good, exactly that. So when they say successive generation, it simply means that you have an initial stage, like here, this is your grid initial stage. After you have next generation, and if you analyze the next generation, all the cells are not more the same. Good, there are some cells that have changed, in fact, maybe from life to death, or from death to life. Good, so it's exactly that. And they are saying that for the grid to evolve from one generation to another, everything depends on the neighbors of each cell. Good. Like if I take maybe cell 1 here, so for him to, cell 1 here is alive, which is 1. Next generation, you are seeing that he's still alive. It simply means what? That for you to determine whether cell 1 should be alive in the next generation, it's based on its neighbors. Good. The different neighbors. And how to do so, they will explain that in the question. So don't stress yourself, don't worry about that. Good, you explain everything. So we continue reading the question. Okay, the neighbors of any given cell are horizontally, vertically, and diagonally adjacent to it. Good. Example, if I take this cell here, this 0 here, so the neighbors of this 0 is, so they say diagonally, horizontally, and vertically. So if you go diagonally, you see that this is one neighbor, this is another neighbor here, so this is already 2. Now this is another diagonal here, this is another neighbor, this is another neighbor, sorry, this is already 4. Now if you go vertically, up here, this is 1, down here, this is 1. Now if you go horizontally, this is 1, this is 1. So you are seeing that 0 is having how many neighbors? 3 plus 3, 6, 7, 8. Good. So this is how we look in neighbors of a cell. Exactly that. So this is exactly what the question have described here. Now, next one, continuation. They say the following rules are applied to the current or initial generation of cells in order to obtain the cell values of the next generation. Good. So now, yeah, they're giving you some rules. These are the rules here. So these are the different rules you are supposed to follow for you to move from one generation to another generation. So let us follow these rules together. Number 1, they say, and as you are following the rules, in fact, you'll be comparing with what you are having here. You see, this is exactly how things work. Because if you compare with what you're having and it's not working here, it seems that there's already a problem in the equation. So let us compare, because here I'm having initial stage, I'm having next generation. So after following this rule, because this rule here is to move from an initial stage to a next generation. Good. Number 1, any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. Good. Now the second point is say any live cell with 2 or 3 live neighbors lives on the next generation. Okay. Now number 3, they say any live cell with more than 3 live neighbors dies as if by overpopulation. Number 4, any dead cells with exactly 3 live neighbors become a live cells as if by reproduction. Now let us interpret both of them with these examples. The first one is say any live cell with fewer than 2 live neighbors died as if by underpopulation. So a live cell here is 1, as I was telling you. Like if I take maybe 1, this is 1 here, this first one here, this is a 1. Good. Now let us verify if this man will be alive in the next generation or not. Now the first rule, I think the first rule match here, because they say any live cell, so it's a live cell, so we continue. Any live cell with fewer than 2 live neighbors die as if caused by underpopulation. So let us count the different numbers here. When they say fewer than 2 live neighbors, it simply means what? That you have a live cell and the number of live neighbors he's having is less than 2. Is it the case for this man? No, because these are the neighbor here. 1, 2, and 3. These are the neighbor of this one here, so only these 3 here. Now, and you are seeing that here we have exactly 2 live neighbor, because here I'm having 1 and 1. So you are seeing that case 1 is not matching. Let us go to the case 2. They say any live cell with 2 or 3, so exactly 2 or 3 live neighbor leads on to the next generation. Like here, exactly 2. So you are seeing that this one match exactly with the second rule. So that's why you are seeing that this one here is still alive in the next generation. Take note of that. Good. Now let us try to take another person. Let me just take this one here down here. You realize that this one here is dead here, it's not alive. So let us see why. The neighbor of this one is 0, 0, 0. So count the live neighbor. How many live neighbor? Just 1, you see, and it's less than 2. So they say fewer than 2 live neighbors died as if caused by underpopulation. That's why you're seeing that in the next generation he's not alive, he's dead. Good. Now let me just take someone else. Okay, so let me take this man. The last example. So this is how you test, in fact. So I think by this level you are really understanding what the question is doing. Now let me take this man here. So you are seeing that this cell here is alive. How many neighbors? 1, 7, 8 neighbors. Good. Now how many live neighbors? So I'm having live neighbor, just fine. Look, this cell with 1. So I'm having 1, 2, 3, and 4. So it's having 4 live neighbors. And what's the question saying? Look here. Look the foothold. They say any dead cell, no, not the foothold, any live cell with more than 3 live neighbors dies as if by overpopulation. You see, so this cell is having more than 3, it's having 4, so it's more than 3. So they say it dies in the next generation. So let us check. Go. This is the position here. Are you seeing that it's no more alive? Exactly. Now let us take something that match 4. They say any dead cell with exactly 3 live neighbor becomes a live cell. Good. So let us look a dead cell in the first generation that is alive in the second generation. So that's from there, because surely if you are alive, if you are dead in the first generation and alive in the second generation, it simply means that you match this fourth rule here. So yeah, this one person here. Good. He said he's dead here, but I'm seeing that in this generation he's alive. Good. So let us try to see how many neighbors. So these are the neighbor here. From here, like this, like this. These are the neighbor. So how many live neighbor? 1, 2, 3 live neighbors. Good. So you're saying that they say any dead cell with exactly 3. Like here, this is a dead cell with exactly 3 live neighbors. Good. They say becomes a live cell in the next generation. And it's exactly what happens here. Good. So you are seeing that the question has been understood. So everything is manipulating an initial grade with some live cells, applying some rule to determine the next generation of cells in the grade. It's all. So there's the idea behind the equation. Good. So by the time you understand the equation, everything becomes easy. Like your mind is now open, in fact, to reason in what you'll be having as pseudocode and so on and so forth. Good. So it's exactly that technique. Now task 2, they say coding algorithm. So here now this is where we'll be writing codes. Okay, so we read, they say we develop a program fragment to display and evolve successive generation of live from a 2D arrays. Good. So they have developed some program fragments. So here they're talking about pseudocode that is created for you. Good. Full stop. Arrays so this is a two-dimensional array, and you know two-dimensional array must have what? Two square brackets, the first one for the row and the second for the column. So here we are having two arrays. Good. So each of them are two-dimensional array. So here the first one is called A. So A is just like an initial stage array, and B will be your next generation array. Take note. Now, so A and B are used to store the current and next generation of the board state. So it's exactly what I was saying. Full stop. Call and row are global variables used to store the size of arrays, and both are initially set to 4. So take note of this. So they say call and for, they are global variable. Good. So I'm going to show you how to declare global variable. Global variable simply means variables that are declared out of functions. Good. So that we can use them in any function without any problem. So it's exactly that. So you are seeing that row and column have fixed value, which is 4. So in this case, we are going to declare row and col as constant. Good, because they have fixed value. So I'm going to show you how to do so. You are to develop executable code from the algorithm given in each subtask. Full stop. For each subtask, make sure the coding is correctly done. Perfect. Good. So we are going to do so. Now the first question, they say subprogram row line. Draw a horizontal line of dashes as follows. Full stop. They say, so here this is the first program that we are writing. This is the function here. The function here is called row line, and they say that the aim of this row line is what? Draw a horizontal line of dashes. Full stop. So mean I draw something like this. You see, of dashes, horizontal of dashes. It's all just a code that displays this. It's all, and the advantage is that they are going to describe how you are supposed to do so. So the question is very easy. So full stop, they say it output a new line. So remember that new line in C programming is what? Is /n. Take note, /n. So it output a new line. So remember the output there you use with syntax printf. Good. So you just need to do a printf where you put the /n in, and you are done with this first part. Comma. Then they say for each column outputs 5 dashes. Good. 1 2 3 4 5. They say for each column. So since the grid is a 4x4, so this column 1 5 dashes, column 2 5 dashes, column 3 5 dashes, column 5 5 dashes. So you are seeing that it's very clear that here you are going to use what? A for loop. Good. So a for loop that starts from 0 and end at what? Less than 4, because if you count very well, the index is what? Is 0 1 2 and 3. So you are seeing that it's very clear. So you just need a for loop that starts from 0 and end at what? Strictly less than 4, because 3 less than 4 you end at 3, and it's all. And from there, or you start from 1 and you end at exactly what? 4, because if you count from 1 year, you have what here? You have 4 here. So it is exactly that. And from there now, when you are doing that for loop, in the for loop, you'll be displaying a printf that prints 5 dashes. It's all. Good. So this is how we reason in front of questions. The next thing they say, after that they say full stop, they say it then output a second new line. So you will do again another printf with a /n. So this is so much. So let's do so directly in the code. So I'm going to open my dev C++. Go. As usual, I'm asking you to save your program first. Good. And generally now the last question is asking you to save your code. So go at the level of your question. Just go at the bottom. They say where is it? There's nothing as save your program. Yeah, this is it here. That you should save them in the file called size8 output. Good. So this is the name of the program. So always save your program, always and always. So I'm going to file new source file, and from there you do your Control S. If Control S not working, you click on file, you click on save as. Good. Now from here you go at the level of your desktop, because you create a folder on the desktop. I've created a folder there. If you don't know how to create a folder on the desktop, just leave a comment. But normally this one, everybody know how to do it. So I assume, good. Advanced level computer science, you know how to create a folder. So this is my folder here, Polar if A level. So now, the name, they say size. I think the name is size 4 array because there's another name up there. So you'll be having 2 programs. So let me just write size 4 array. Good. So after doing that, the next thing is at the level of save as type, click on the drop down button, you choose C source file because we are writing a C program and not a C++ program. Some students are always doing this mistake. You click on save. Good. So this is where we are going to write our code. Now, the first library that you always include is hashtag include stdio.8. So this one is not optional. Why? Because this library is helping you to use input and output function. Example of an output function, printf. And since the characteristic of a good program is that it should produce at least one output, it simply means that whatever you are doing here, you must display something. If you don't display something when you execute your code, are we just going to see a black screen? No, we must see something. So it simply means in all the programs that you are writing, you must use an output function. You must use printf somewhere. So that's why this first line is always there, because without this line you cannot use printf nor scanf nor any other input or output function. Take note. Now after that, the next thing is we start with our function. So let me just arrange this. Okay. So now the next thing is there's what we call function, there's what we call procedure. So a function is a block of code that solve a task and return a value. So generally you are using function when you are doing some calculation, in fact, because after doing calculation you return the value. So this is just a particular case, in fact. But generally when you be having a pseudocode, in your pseudocode, just try to identify if you have something like return a particular value. It simply means that that block of code is a function. Good. And generally the syntax of the function, I think everybody knows very well how it works. If you have any problem there, just leave a comment. Now in this case, what happened is we are just trying to write a sub program that display lines. So you are saying that this is a procedure because we are not returning any value here. We are not doing any calculation. Good. So for a procedure, you start with void. And the name of the procedure is say row line. Row line. Good. I open, I close. It's not taking any parameter. Remember that the parameters are the inputs, in fact, we need in the function. So yeah, we don't need any input. Good. So you open like this. Now what's the question saying? They say it output in new line. So printf /n. So you see, I'm not creating something, I'm just following what the question is saying. Then they say okay, for each column output 5 dashes. Now see here, I'm going to declare a variable in I. Okay, now I'm going to move, and the next thing I want to mention also is generally when we are writing programs, it's not as if you have everything in mind at the same time. No, it's when you are writing your program that if you realize that you are missing something, you go and add it inside. It's exactly that. Like here, you see, I did not start there with in I. You see, simply because I missed out that I'm supposed to declare I because I'll be using it here and there. You see, good. Just to tell you that always go gradually. Don't stress, in fact. If you find yourself in a situation where you need something, a variable, go and declare it, no problem. Good. So now I can start with my for. So for I equals to 0, I less than, now less than what? Less than call, which is 4. Good. Less than call. Now I plus. But you realize something, that call is not yet initialized, it's not yet declared, in fact. And remember that the question said that call and row are global variable with constant value at 4. And I told you that when you have constant value, this is how we declare constant. You move after this hashtag include, you write hashtag define, comma, you give the name of your variable. Let me start with row, then you put space, you give the value. Good. It simply means that any place in my code where I use the word, the variable row, and indirectly using what? 4. Good. So generally, in fact, this to make our code very easy for modification later. Like tomorrow, imagine that the row is 8. I don't need to go in the code and change 8 everywhere, no. And change 4 to 8 everywhere, no. I just move at the level of my constant, changes 4, I put 8, and the code is okay. So anything that have a row in the code, we use by the value at 8. Good. So call is the same thing. So for call, hashtag define call, and they say what? 4. Perfect. So where I'm using call here, I'm indirectly using what? 4. So if you remove this call and you write 4 there directly, it's still working. There's no problem. Now, so in this, what are we displaying? We are displaying print f and the printf, you are displaying how many dashes? 5. So a dash here is underscore. So 1, 2, 3, 4, 5 is all. You put your semicolon. So here you're not putting any /n here. No need to do this. No. Why? Because /n means new line. So if you're putting /n, it's a save. So you're going to display the first 5 dashes. Then the second first 5 dashes will appear where under, and so on and so forth. All this is not what we are trying to do. Everything should appear on the same line. So there's no /n. Now, so after this is all. So after the for loop, so the for loop will display that line, and they say out of the for loop, they say you print another new line. So just copy this. Good. Generally, don't waste time to recopy something. You can just copy and paste, and it's all. I'm done with the function. It's all. So this is all what the question is asking. So continuation, we go back to the question. So at the level of the question, number 2, they say implement the LCG random number generator given in figure 2. Good. So LCG here in fact is linear congruent generator. So generally it's an algorithm used to generate random numbers. And as I'm always saying, no need to know the algorithm. Don't stress yourself to say you want to know the algorithm that generates random number. It's not necessary. The algorithm that are describing for you here. So translate is all. And when you're translating, what's important is to look at something. You know already that the aim of this algorithm is what? Is to generate random numbers. And the random numbers they are talking about is this 1, 0 you are seeing in cells here. Good. Like the initial stage, in fact. How are we having the 1, 1, 0 and so on? They are random numbers. So the aim of this function is to generate that random number. So as I was saying, by the time you understand a question, it's all. You just work smoothly without any problem. Like here, I don't need to know how this algorithm works, but I just know that the output of the algorithm should be a random number, either 0 or 1. This is what I know. Meaning what? That when you translate this algorithm, you test it to verify if it is giving what you are expecting. If the thing is not giving what you are expecting, then you cannot enter in the code in detail and say what's not working, things like that. But generally in the exam, don't waste that time. You don't have time. Good. Now, and there's something I forgot to mention is each time you are writing a function or a procedure and you have the opportunity to test it. Very important. Like here, let us test this one first. Now remember that to execute your different function, you declare your main program. So in main, because remember that the main here represents the door of the compiler to execute your code. So you cannot write function, because I'm seeing some students doing some mistake. After writing function, the man come and click run to execute, or compile and run to execute. No. Compile and run to execute that you have called the function. When you write a function or a procedure, you must call it in fact. Good. And you must call it in the main program. Good. You can call it in another sub-program, but at the end, in fact, that other sub-program, you still call it in the main, because everything is being executed but in the main. So here I want to call the procedure whole line. So how to call procedure? To call procedure, he's not returning any value. Good. Since he's not returning any value, no need to declare a variable that you say. Let us say you declare a variable r, you come and say r equals to whole, and no. This way of doing it is when you are having a function that return a value, so that when you call it like that, the value returned by the function is being stored in that your variable. Good. So yeah, it is just a procedure. So to call it procedure, just give the name, and if the man is having any parameter, you pass the arguments here. So arguments simply represent the value in fact of the different input taken by your function. But in our own case, this is empty, so that's why I'm just calling opening and close, nothing else. Good. So you put your return 0 as usual. I think everybody know the basic structure of the main program. It's all good. So Control S to save your code. Control S. If Control S is not working, click on File. Just click on Save. In fact, I've saved it already. But here you click on Save, not Save As. Good. Always do so. Now to execute, you move at this level. You will see compile and run. So this is not the first time I'm explaining the use of this, so I'm not going to waste time here. So just click. When I click, let us see the output exactly. Are you seeing the lines? So everything is perfect. So when you have something like that, you are sure that your program is working good, so that when you go to the next function, you will do same. So always test your code, because sometimes they are writing without even testing. At the end, they are blocked because they cannot correct errors. Good. So have this habit. When you have the opportunity to test it, because there are some functional procedure that we cannot really test if you don't complete the equation. That one I know. But things like this, we can really test it. That's why I'm doing so. Good. Now the next thing here, they say implement LCG random number generator given in figure 2. Okay. Follows the direction given in italic. So if you look this pseudocode here, you realize that this italics here, this is here, this is another italic text. Good. So the italic text are just like comments, in fact, like telling you what you're supposed to do. Is all good. And beside that, you also have some comment also telling you what the instruction is doing. So you're seeing everything is being explained for you, so you cannot really complain that you're not understanding. Yeah, so we are going to follow the directive. Okay, now continuation is say you will later call function run init. Run init is taking what in parameter? S. Good. So don't think that S here is plural of init. No. So this is the name of a function here, and in bracket is taking what? S. So what you have S here is just a parameter. So if S is an integer, you will declare in S inside. So it's all. So you will later call function run init in order to initialize the random number generator. Full stop. Similarly, you will later call function run no, which is not taking any parameter, repeatedly in order to return successive random number. So yeah, if you realize something here, we have two functions. We have this function run init and the function run no, run number, something like that. Good. So it simply means that from the pseudocode, we are going to see this function and just translate them. Is all. So here in the box they say define the global constant run seed equals to 7. Good. So you know how to define constant. So you move inside your code, you say hashtag define. Good. The name of the constant is what? Run seed. So please, at the level of names of variable, write exactly what you are seeing in your pseudocode. This is my advice, because some of you are funny. You write run seed and the A, you'll be writing it in small letter. Then in your code, when you are translating, you use again capital letter. At the end, nothing is working. You don't know why. So always make sure that the name given in the pseudocode, just use it like that without changing anything. So run seed, 7. So I've declared my constant. So anywhere in the code you use run seed like this, you write this, you are using what? 7. Continuation, interpretation of the algorithm. So you are done with the first interpretation. Now they say the next italic text is saying what? Define the global variable with an initial default value. Run x. So this is here. Run x is taking what? Run seed. Good. Now here, what happened here? We have another variable called run x, and run x is taking what? Run seed. So you are seeing that here run x here is not a constant. He's taking run seed. It's meaning that run seed here. If run seed change, this man will change also. You see, good. That is why for this one, run x here is just a variable. When you say global variable, it simply means that you must do it, declare it up here out of all the different functions you'll be writing. So here I'm going to say int run x, and they say that it's equals to what? Run seed. So generally just copy paste. No time to waste in the exam. Good. Then semicolon. Now there's something else. Another student can move and do this. Run x, then go to the next line and here write run x equals to this. This is not going to work. This is not working. Why is that this is not working? Because when you are working with a global variable like this x, you see that I've declared x out of function. I've declared run x out of function. Run x is not inside a function. It's not in the main, it's not in any function, in fact, you see. And when you are not in a function, it's not possible to declare and then come and initialize after like this one. No, it's not possible. This is only possible when you are inside a function. Take note. So these are things that when you don't practice, you never know this, in fact. You never know it. Good. So please, let me just go back. Good. So yes, say it's a global variable. When you declare, you initialize it directly. So this is how global variable works. So take note. So continuation. They say in the next italic they say define function run init in bracket taking s as parameter and run number taking nothing in parameter. Good. Now they say set. So under they say this is a small comment. So remember the true line here is for comment. Set initialize the random number generator with integer s, where s is between the range what? S should be greater than 0 and s should be less than 16. And here the function here, function run init is taking one in parameter x. Are you seeing that s here is an integer? The question is not okay. The question is even precise. They say the random number generator with integer s. So they are already telling you this, the data type. But just from this condition, we are seeing that s is an integer. So this the function here, function run init taking what in parameter s. And here we have something like run x equals to s. Good. But remember that before writing this line, make sure that you test this condition. So here we are going to use an if. to verify if S is between this range. If S is between this range, then you say run X take what? S. Because the question have precise that S must be in between this range. Take note of that. Good. Now the question you ask yourself, is it a function or a procedure? It's very clear this is a procedure. Why? Because when you look inside this function, are you returning a value? You're not returning something. There's nothing as return. Good. So you mean that here you have your procedure void. Good. The name is what? The name is what is it? Run exactly how you are seeing. R is in capital, so maintain that. Run init. Good. So taking what in parameter, taking S. So in S. Good. So you open. Now remember that here you test your condition. If S is greater than 0, and so this is how you write and here with the and this double thing, and S is what is less than 16. Good. So if this is the case, what are we doing? They say in the algorithm, they say run X is taking what? The value of S. Now you ask yourself, else, what are you supposed to put at the level of else? Else is very clear. If S is not in this range, it simply means that run X cannot take the value of S. So the else here simply means that run X should take back the value of what? Of run set, you see. Good. But yeah, I don't really need to put the else. Why? Because run X is a global variable. So when you test your condition, if you don't enter here, automatically the run X will still maintain the value run set that it was having at the beginning, you see. So no need to come and say again else run X equals to run set. No need in fact, because if you don't enter here, run X will maintain here value, because remember that before entering here, run X is already having a value which is 7 from here, you see. Good. So the S says just to change the value that he's already having. Good. And if S is not in this range, it simply means that we are not changing the value of run X. Run X is staying by with the value of run seed. Take note of that. Just to tell you that if you move at this level, you put else, run X equals to run seed, there's no problem, it's still correct. Good. So I just want to make my function to be very short like this. And generally I like to do this in the exam. After writing one function, you put a comment, you put lines here. Good. So it's not affecting anything in the code, it's just a comment. So I'm done with the first function. The next here, let me just put my line and draw like this. Okay. So the next, from the algorithm, go at the level of the algorithm. They say return the next random number. Good. So the function here, function run number, nothing in parameter, and then inside they say run X equals to 5 times run X plus 3 mode 16. Then they say return run X mode 12. And the comment here say that this instruction here is returning either 0 or 1. Good. So in the GC board, you see they did a mistake. Where you're having this 12 is 2. So take note of that, it's 2. Good. Things that in the exam, don't stress. If you see 12, you write the 12. If there's a mistake, just surely they will just come and inform you, the people, that okay, this 12 change it to 2. Good. Now, so yeah. Now the next thing is, you are seeing that this function is having return something, returning a particular value. And that value is either 0 or 1. So it's very clear here, it's a function and not a procedure. And remember, a function is having what? A data type. So what should be the data type of this? It's very clear. So you are seeing that C it returns 0 or 1, which is an integer. It means that the data type of the function run number is what? Int. Good. So this is how we determine it. So in the name of the function, run, no, exactly like this, nothing in parameter, you open, you close. Then here you say run X is equals to what? Is equals to 5 times run X. Are you seeing that in the code here? They're writing run X using small r, or up here they say that run X is capital R. So you're seeing that this is a small mistake. So in your code, make sure you use the capital R. Good. Because you know C programming is a variable here, very case sensitive. Variable, name of function, all these things. So don't go and use small letter and come and use capital letter. No. So take note of that. So here you need to be very active to see it, because I remember some students, they are always doing this mistake. Always and always. So please. So modulo, this is how you translate modulo, by just putting percentage. Good. And this modulo percentage, they are saying it in the question paper. If you read till the bottom, you see it there. So that's why I'm saying exam is very easy. But at least this is a minimum thing you must know. They don't need to mention that. Good. So here I'm going to say return. Return what? You put return space, you open. They say run X. ran x modulo, which is percentage modulo what I said that here is 2. Okay, so semicolon, and it's all you are done. Now since you are done, you are supposed to test if this thing is working. You are supposed to test it. Like, let us write a program. Let us call them in the main program and see if ran number here will return 0 or 1 as you are expecting. Now to do so, you go at the level of your main code. Now the first thing, what is the equation saying? That call ran init first, because in the order in which you are executing it, they say that in the equation. Good. So the whole of ran init is to give an initial value to what? To ran x, and ran x is now being used in the function what? In the function ran number. That's why the first thing is to call him. After calling him, now you can call now the next function, which is what? Ran number. Now, but yeah, remember ran number is what? Remember ran number is a function, not a procedure. So he's returning a value. Since he's returning a value, it simply means what? That you need to declare a variable that will store the value that he's returning. And he's returning what? An integer. So let me just declare a variable here in, let me just call it maybe r, like this. So that when you are calling him at this level here, you'll be saying that r is equal to, now you give the name of the function. Is he taking something in parameter? No, you give the name of the function like this. This is how we call it. So that the value that is returned by ran number will be stored in what? In R. And I did a small mistake. Ran in is taking what? It's taking a parameter. It's taking a parameter S. Good. So remember that the parameter, when you are calling it, you are supposed to pass the value. So for S here, let me just choose the value 8. Let me just put 8 like this. Good. So don't forget, don't come and call ran in, you don't pass something in parameter. It's not correct. You don't pass something as argument. Sorry. When we are calling, what we are passing is called argument, because it's the value that will be sent in the function. Good. But when you are declaring your function, what you are passing in here is just what we call a parameter, like the input is all. Now, so the next thing. So at this level, what happened is R is containing the random number. Now we need a printf to display and see the value of R. So I'm going to just say printf. Good. So inside my printf, let me just say something like random equals to what? Equals to the value coming from R. So R is an integer, so you write percentage G. Then you go out, you write comma, and you write what? R. Good. So that the value in R will be displayed here where you have the percentage G. So this is how we display a value from a variable. Control S. So execute the code. Random is what? 1. Perfect. Now let us change the value again of S. Remember, when you change the value of S, the random value can change also. It depends. Let us see. Yeah, you have changed to 0. So you can test. So I don't have time to test multiple times. But you see now everything is perfect. Okay. So, and this is how you're supposed to work in the exam. Please always test what you are doing. But at the end, all what you are having in the main year, you clean it, because there's one part in your question paper that will tell you how you are supposed to call them. Good. Now, so we are done with this. Good. So I think this video is becoming very long. So we are going to end here. So part 2 of this same year, we are going to continue from question 3 till the end of the paper. Good. So if you have enjoyed the video, leave a positive comment and see you in the next video. Ciao.